Welcome back to Aerospace Engineering Enclave. Today we're diving into one of the most critical concepts in high-altitude flight, the Coffin Corner. It's not just a myth, it's where aircraft performance walks a tightrope between stall and overspeed. Let's break it down. Oh, and don't forget to like, comment, and subscribe for more aviation insights. The Coffin Corner refers to a condition at high altitude where an aircraft's stall speed and critical Mach number, sometimes called Mach buffet, get dangerously close together. At sea level, you've got a wide margin between the speed where the wing stalls and the speed where airflow becomes compressible. But at higher altitudes, air density drops, stall speed increases, and the speed of sound drops, meaning your safe operating envelope tightens dramatically. At the Coffin Corner, your aircraft is flying dangerously close to both its stalling speed and the Mach buffet limit at the same time. This is a unique and critical region in the flight envelope, typically encountered at very high altitudes, where the margin between the lowest safe speed and the highest safe speed becomes extremely narrow. This phenomenon occurs because first, as you climb higher, the air becomes thinner, and the wing reaches its critical angle of attack much more easily, increasing the risk of an aerodynamic stall. At the same time, the aircraft is flying close to transonic speeds, where shock waves begin to form on the wings, causing flow separation and what's known as Mach buffet, a turbulent, unstable airflow that can shake the aircraft and reduce lift. In this precarious zone, it becomes almost impossible to maneuver or recover from upsets, especially for aircraft with high wing loading or a poor thrust-to-weight ratio. Even small control inputs can push the aircraft beyond safe limits. By the way, Coffin Corner is a major design constraint for high-altitude aircraft like the U-2 spy plane and the Concorde, which operate right at the edge of this narrow flight envelope, requiring precise piloting and careful engineering. So, why should you care about Coffin Corner? It might sound like a technical detail, but it's actually a critical concept for anyone interested in aviation safety and high-altitude flight. Even in today's advanced aircraft, with sophisticated flight envelope protection systems and automated warning systems, pilots and engineers must always account for the risks posed by Coffin Corner. This becomes especially crucial for long-range jet aircraft, high-altitude surveillance planes like the U-2, and any aircraft that regularly operates near the upper limits of the atmosphere. Supersonic transport jets, such as the legendary Concorde, also had to deal with these challenges, making precise control at high speeds and altitudes absolutely essential. At those extreme altitudes, the margin for error is razor thin. Just a small overspeed, a sudden gust of turbulence, or even a minor miscalculation can lead to a dangerous loss of control. That's why aircraft operating near Coffin Corner require extremely precise autopilot tuning, reduced bank angles to avoid excessive stress, and constant monitoring of flight parameters. Pilots must manage their speed with great care, making small, deliberate adjustments and staying alert at all times to ensure the aircraft remains safely within its flight envelope. The tragic crash of Air France Flight 447 in 2009 underscores the dangers of Coffin Corner. Ice crystals obstructed the aircraft's pitot tubes, leading to false speed readings. The crew's incorrect response caused the aircraft to climb beyond its safe operating altitude, resulting in a fatal high-altitude stall. If you're a pilot, then you need to understand why Coffin Corner is one of the most dangerous places in the sky. In aerodynamic terms, Coffin Corner or aerodynamic ceiling refers to the region of a flight envelope where the aircraft's critical Mach number and stall speed are within just a few knots of each other. This means that flying any faster will cause airflow over the wings to reach the speed of sound, leading to flow separation and a sudden loss of lift. But flying any slower will stall the airplane, also causing a loss of altitude and control. In both cases, the aircraft can fall out of the sky with little or no warning, and almost no chance for recovery. The term coffin highlights the deadly risk of losing control at these altitudes, while corner refers to the triangular shape at the top of the velocity height diagram that marks this critical region. Pilots must stay clear of these regions, and constantly monitor their speed and attitude to avoid disaster. The Coffin Corner is that intersection of a given aircraft's stall speed and its critical Mach number. While stall speed is fairly self-explanatory, the critical Mach number is the lowest Mach at which airflow over any part of the aircraft reaches the speed of sound. As an aircraft climbs, the margin between these two speeds shrinks, making it harder to maintain safe flight. The real name for this phenomenon is the Q corner, since Q is the official abbreviation for dynamic pressure. But the term Coffin Corner has stuck, both for the triangular region on the flight envelope chart and the very real danger it represents. When an aircraft is in the Coffin Corner, even small changes in speed can be catastrophic. Reducing speed can cause a stall, while increasing speed can reduce lift and trigger a Mach buffet. Either way, the aircraft can lose altitude rapidly, and the resulting G-forces can cause structural failure, sometimes leading the plane to break apart. Let's recap the essential concepts about Coffin Corner, Q corner, or aerodynamic ceiling, and why understanding this phenomenon is crucial for anyone involved in aviation. It is that point in the flight envelope where the boundary defined by a high incidence stall intersects with that defined by the critical Mach number. In other words, for a given aircraft weight and G-force loading, it's the altitude where the speed difference between the onset of low-speed stall buffet and the onset of high-speed Mach buffet approaches zero. As an aircraft climbs toward this altitude, the margin between stall speed and critical Mach number shrinks until the flight envelope boundaries actually meet. At this point, any change in speed, slower or faster, would push the aircraft beyond one of these limits. In the most critical situations, even a simple turn can cause the inside wing to slow down, and the outside wing to speed up, potentially exceeding both boundaries at once. Similarly, turbulence can cause sudden changes in airspeed that push the aircraft beyond safe limits. That's why, in both commercial and general aviation, flight at altitudes near Coffin Corner is generally avoided. Pilots and operators rely on the aircraft manufacturer's maximum operating altitude, as specified in the aircraft flight manual, to ensure there's always a safe margin between stall and Mach buffet boundaries. If turbulence is encountered or forecast, the recommended practice is to reduce cruising altitude to maintain adequate buffet margins and avoid compromising safety. Have you ever operated near Coffin Corner, or do you have questions about what it's like? Share your experiences or let us know what high-altitude topics you'd like us to cover next, maybe Mach tuck or other flight envelope phenomena. If you found this explanation of Coffin Corner insightful, don't forget to like, subscribe, and hit the bell icon so you never miss an episode. Thanks for watching, and see you in the next video.